Good morning, everyone. We are into the second day of 2 days international conference on recent trends in computer science and engineering. The presentations are going parallelly in two rooms, room number 1 and room number 3. We are into the room number 3. The session chair for this room is Dr. D.S. Kushwaha. He from MNIT Allahabad, Uttar Pradesh. He is an associate professor. He has done his PhD, and his areas of interest are distributed system, service-oriented architecture, software engineering, operating systems. He has guided almost 10 students in PhD, and of which 3 have completed their PhD. He also has 100 papers published to his name. The co-chair for this session is Dr. Jainath. Dr. Jainath Yadav. He is about to complete his PhD from IIT Kharagpur. I would like to welcome them with the chair with a bouquet of flowers and a memento. I would ask Jainath sir to present it to the chair. Now I would like to ask Ragini to hand over the files to the chair and session chair, co-chair, sorry. First person to present his paper is paper ID 24, Dr. P.K. Sharan from DRA University. Dr. Sharan, please. Sir, he will find.
Well, myself Dr. P.K. Sharan from DRA University, and the topic of my paper is a comparative study of software engineering design principles, model, processes and methodologies. I'm co-author of the paper, and you see the in universities, traditional universities in Bihar, the computer science department is a recent one. It is still being run under the Department of Mathematics. Not enough work, not enough support is there towards the research scholars. But we have planned so much things, and in the coming days, quality of the research will be better. So, if there is, at the moment we are not going for a good number of research in core areas. So the topic of the paper was a comparative study. Now let us come to the various principles on which a software software is designed. We know the first principle is known as separation of concern. Separation of concern is basically a manifestation of division of labor. You see, a big software is designed by a good number of modules, and various modules are again divided into sub-modules, and various sub-modules are still divided into various functions, and we start applying what is known as top-down approach. And when we go on breaking the large software into a smaller module, still we are able to apply solutions to individual sub-modules, and we integrate and finally get a good software. The separation of concerns is the basic functionality should be separated from support or data integrity as far as possible. Meaning that when we are using software, when we are having methods and data. When We are using methods, it changes data, but when we finish, the data must bring back to the original state, and this is called separation of principles. The second important principle is modularity. Complex problems are divided into, I have already explained, into smaller subproblems following the top-down approach, and the solution to each subproblems are applied when we integrate them into working software. This is known as modularity. Abstraction. Abstraction means separating the behavior of the software components from their implementation, or may result into undesirable coupling. Anticipation of change. You see, when we design a software, often software is designed in increments. So, the important principle is anticipation of change. The business rule changes, and it may be required to incorporate various other functionalities into an existing software, and we anticipate that software will change. Software defines the type of data and relationship between them. However, software developers deal with data in an abstract way. Generality. Software should be of the general category so that the change management is easier and faster. If it is a specific, the change management will be very difficult to incorporate later on. Incremental development. Most of the software are developed in increments. Software must be developed in increments following use cases, and it helps debugging and testing as well as maintenance of consistency. Then let us come to the various principles on which the software is designed. First is open close principle. Software entities like classes, modules, and functions should be open for extension but closed for modifications. Dependency inversion principles, DIP, the high-level modules should not depend on the low-level modules, rather both should depend on the abstractions. Interface segregation principles. Clients should not be forced to depend upon the interfaces that they don't use. Single responsibility principles. A class should have only one region to change. A responsibility is considered to be one region to change. Substitution principle. Derived types must be completely substituted for their base types. The new derived classes should be able to replace the base classes without changes in the node. Let us now come what is known as system analysis and design and object-oriented analysis and design. They are the paradigm which is mostly common in the present scenario. A system analysis and design is the process of developing information systems that effectively use hardware, software, data, processes, and people. SDLC and SAT are cornerstones of the full lifecycle product and system planning. Object-oriented analysis and design would provides a very productive and practical way of software development and is language independent. Being language independent, it can be used with all the languages. Let us now come to software development process or software development life cycle, which is in short known as SDLC. The system development life cycle, SDLC, is a group of activities like investigation, analysis, coding, testing, implementation, and creating or altering information system, and includes the models and methodologies used to develop these systems. ISO IEC 12207 is an international standard for software lifecycle processes. It aims to be the standard and that defines all the tasks required for developing and maintaining software. The first is management and control of SDLC. It is critical for the project manager to establish and monitor control objectives for effective project management during SDLC phases. Work breakdown structured organization. The upper section of work breakdown structure describes the milestones of a project and timelines. The middle section of the 7 layers of SDLC phases in terms of milestones and tasks. The lower section, task, activities, and their coordination. These things are in software project management itself. And baselines in the SDLC. Baselines are milestones. Among various activities have various milestones for iterative nature of the model in SDLC and are established after 5 of the 7 phases of the SDLC. Let us now come to models and methodologies which are prevalent in the current scenario. The prescriptive model is an older one. They prescribe process tasks, development activities, quality control and change control mechanism of the project, and is suitable for any type of projects in which these elements are clearly discernible before the start of the project. Waterfall model is an important and most popular model, and it is based on sequential approach to project development, starting from the investigation and planning and passing through analysis, design, coding, testing, implementation down to the maintenance phases of the SDLC. It can be used in new projects only when the requirements are clearly known at the beginning and is more suitable for enhancement of existing software rather than developing the new software itself. The incremental process models are suitable for those projects in which the requirements are mostly known prior to the development, or when there is necessity to develop, an early version of the software, or something like prototype with limited functionality, followed by a comprehensive versions of the software which can be developed by further increments and enhancements. First is the incremental model. It is a combination of waterfall and incremental model. In the first increment, the core product is developed, which is enhanced in successive iterations. It is useful for organizations having a scarce manpower and where product delivery schedules are to meet deadlines. Second is RAD, or the Rapid Application Development Model. It is also a very popular model. It involves iterative development and construction of prototypes which lay an emphasis on short development cycle. It is suitable for those projects in which requirements are well known in advance and project scope is limited. It is ideal for modularized business application development having a scalable scope, in which case the RAD model can construct the prototypes in even less than 3 months. So when short development time is there, this model is very suitable for those projects. Let us now come to evolutionary process models. They are iterative in nature and accommodate for changes in requirements and are suitable for limited version of the project meeting the competitive business pressures, and that can be enhanced in successive versions by iterations. When the requirements from the system is not very clear from the beginning, or when a scope of the project may be enhanced in future, evolutionary models can be used. The first is prototyping. When we start a project on a large software project, and sometimes there is not enough time to develop it. You have very limited time. We go in for prototypes and get it installed, and from successive iterations by changing requirements we go on developing the software itself. So when the requirements are poorly stated, human-computer interface is not clearly identified, and user acceptability is an issue, prototyping becomes an inevitable choice. In this model, a working model of the software is developed quickly on the basis of the available requirements and the problem areas identified to be tackled in forthcoming version. It is not suitable for high-quality products or where development schedule is tight. Otherwise, it will not give you better results. The spiral model is again a very popular model. It is a combination of iterative nature of prototyping and systematic approach of waterfall model. It is suitable for large software projects in which the business rules and requirements change and they have to be incorporated in future. However, in contract-like situation, it is difficult to convince the client about the evolutionary nature of the software. Moreover, risk analysis and its control requires a skilled and experienced workforce. Third is the concurrent development model. It can be applied to any type of projects and is particularly suitable to networking projects where changes of states trigger various actions. Specialized process models have also been devised, and the first is the component-based development model. It is a combination of a spiral model and pre-packaged software components. It begins with the identification of the candidate components, which can be conventional software modules or object-oriented classes or packages, or passes through the research and evaluation of components to find their applicability, designing architecture to accommodate the components, integration of components, and testing them for desired functionality. This model offers a number of advantages such as reusability and subsequent cost reduction, and is particularly suitable. Actually, a number of models has been compared, and I have prepared suitability. So, these models, for example, extreme programming and other advanced models have also have been devised, and it is it suggests a set of innovative and powerful techniques that help the Agile team to create frequent versions of software according to the need of the customers. So it is suitable for most of the modern day business applications development where the customers are guided by the economics of the market. Then the adaptive software development is suitable for those types of projects that are more scientific and yeah. Actually, the things are still in progress, so it was just initial presentation. The case studies are there and it is in progress, so that cannot be. So, any questions?
Yes, I have a question. Don't mind it. I don't know anything about it.
Okay.
What is the good contribution in this? Because
You see, a number.
Because there are more than conferences, there are more than 100 papers for all the models. More than 100 papers. Even some of my students know that how to find the contribution on the author, find the
Okay, we have.
Criteria they have included from author side that in which parameters you are going to be loading. If you have developed any deviation criteria,
we have obtained various data from the for companies, and we are in the process of comparing these results by analysis, and case studies are there, but it is in progress, so it cannot be incorporated at this moment.
Where the customer is very fast, not only Microsoft and IBM, they are directly going to the external area of the this is the final result what you are going to get. So, and it is already approved by the company and others. I thought that what you want to extract from the information from the study.
Actually, the case study is about the comparing various projects. If it has followed this model, this result has been obtained, and if it could have followed this model, then this result would have been obtained. And this case study is still in the progress. So at the moment, we don't have much results to show you. We just have. You see, soliciting information from the companies in India, it is very difficult. They don't part with their data easily unless it is pursued. So that is there. But it has been consistently pursued. We are in the process of making case studies.
In 1998, during my service, I did MTech from Indian School of Mines, Dhanbad, and after that I did PhD in computer science from Kashmir University. As I told, presently I am professor and head department of computer science. My research area is software reliability, software testing especially, but unfortunately I am not going to present this paper, a paper in from the software reliability field. One of the paper that we have written, especially my scholar Dr. Majid Zaman Baba has written this paper, e-governance development agile perspective, and I'm going to present that paper. So let us start. What is government enterprise? Government enterprise requires interaction with various systems, including citizen, business, and government, thus resulting in establishment of numerous subsystems within the enterprise, as for example, account, state, budget, HRM, information technology, etc. It is not to be confused with e-governance, but IT supports day-to-day functionality of the enterprises. I missed this point that I'm not going to present any contributory paper. This is a review paper, review of research. Winston Royce, according to the Winston Royce IEE paper, managing the development of large software system, there are steps required to be followed by software developments, regardless of size and complexity, known as waterfall model. Everybody in the field of computer science knows that waterfall model is very important in software development life cycle. Waterfall development methodology has hard requirements, including scope and functionality, cost, time, etc., having serious dependency upon a precise requirement and design with clear technology and business logic. Means that in waterfall model, SRS, software requirement specification, is very hard, and one should know first the SRS, and then we can further proceed. Then another a group of authors in their paper, Spatial Data Infrastructure, SDI and e-governance, a quest for appropriate evaluation approaches. This is the title of the paper. They have given emphasis that a government-centric perspective in SDI evaluation.
Know that whether
in another paper,
you are familiar
Claudio
over NS2.
Sibra,
So are there some results?
Claudio Sibra in his conceptual paper titled Interpreting E-Government and
Other
Development.
So have you compared your
transparency
or
or
architectures and you have comparison
government
table or not?
at the distance, discusses through the case of Jordan how e-government is difficult to implement given the characteristics of the local administration and socio-economic context and dynamics of the technology infrastructure. What is government services? As we know, government services in India.
Your algorithm as well
We
as
have
existing your architecture and
we have central universities, state universities,
and you can
as you know,
paper to
and numerous
okay, thank you.
students in any state university, or you can say thousands, more than 5,000 in central university, as well as state university, as far as the central institute is concerned, hundreds or very less students are available in the central universities as compared to the state university. I mean to tell you that the heterogeneous population in the different government organization. And waterfall model in which SRS, software requirement analysis, is essential. Waterfall model phased manner of development where in process of moves from one phase to another in sequential manner. Once the requirement phase is complete, which is considered as writing on stone. By many critics, it's only when requirements are complete, process proceeds. Until the requirements is complete, we cannot proceed the process. Okay, I will complete within 15 minutes. Given time.
You had 15 minutes and that is over.
I have been told that we have to.
I want to start with the student safety first.
Okay, I will conclude as early as possible. How much time I have just now?
For discussion, you will.
Ah.
For paper, it will.
But give me some time, I will complete. Okay, let me complete.
Yeah, you can complete.
Okay. Then what is agile computing? Agile computing is interactive and incremental way of development. Means that in agile computing, it is not like waterfall model that SRS must be known first. In agile computing, we take a smaller problem and even all the requirements are not necessarily known and we proceed. And based on the feedback, we refine incrementally and iteratively. And after the completion of every iteration, we test the software and go for further refinement. This is the benefit of agile computing. And why we have chosen the agile computing e-governance project? Because in e-government projects are based on the government interference. Means that sometimes government changes, sometimes government faces the financial implications, and for that delay happens. So at that time there is a chance that, or ample chance that the requirement changes. So requirement changes, then in a waterfall model, it is very difficult to go back to SRS model, software requirement analysis. And even if we go to the sort of requirement analysis again, then the cost will be drastically enhanced. So in this way, agile computing, by nature of this method or development method, we choose agile computing because it is iterative and based on the available resources, infrastructure and requirement, we can develop software. And yes, we have project for DST, from the DST, about 5 crore cost of the project. E-governments in Kashmir University, as well as no. Educational institution interconnectivity and e-governance of university. So, for example, we have a campus in Ladakh and private colleges in so many remote areas. we facilitate in connecting using internet or intranet. Yes, very successfully. But it is in the phase 2. We are in phase 2. Phase 1 has been completed and successfully. Then government of India has given 7 crore rupees further. And for phase 2. And in phase 2 we have planned to connect Leh and Ladakh and other remote areas. Phase 1 is for University of Kashmir and nearby districts. We are going to connect using available service providers like BSNL. BSNL, I told you. Okay, no problem. We will start from 2G. No, basically in Jammu and Kashmir there are 2 parts. One is Jammu region and other is Kashmir region. So we have a project for Kashmir region only. In Kashmir region includes Leh and Ladakh and Gurez. I don't know about Jammu division because we have project for Kashmir division. And in initial phase we have completed towns nearby the Srinagar.